Okay. Yeah, we're recording. Fine. Hey everyone, welcome to the last session for this course in problem solving for this course. Um, as discussed yesterday, we'll do a quick rundown of the entire syllabus. So we'll just I'll ask a few questions, and then from there we'll see how where we need to spend some time or something like that. Okay. Um, and again, please feel free to either just unmute yourself and answer, or you can put on the chat. Chat will take a bit of a time, but I hope that that is okay. Yeah. Um, Fine. Just a moment. I need to set up a few things. Yeah. Hmm. Chat. Okay. Yeah, so we'll start with the basics in this Python series, right? Anyone want to tell me what's the different types of data we can have, for example, in Python? Um, what type of numbers are possible? What types of other types are possible in Python? Anyone?
Integers, integer,
Yes, correct.
integer, float, boolean.
Yes, so we have int, float. So these are mainly for your numbers, correct? Then you have
Yes,
boolean.
boolean.
Yes. What else? Strings, correct?
Yes,
So strings are also a special type in Python, right? Trees. So trees is not a type in Python by default, right? It's something that we define. So these are your we have defined that class tree and then try to use it. That's the object-oriented concept involved in Python, right? So trees I wouldn't call it as a separate type altogether, right? Um, Yes, dictionary and all that. Yes, that's correct. Yeah. So all of these again, they are ways to store data, right? Um, right. Then let's say if I have a number, right? Let's say A, and if I do star star B, what does this mean? What does A star star B mean in terms of
exponentiation, a to the power of b.
A to the power of B? Correct. This is A power B. Correct. Then can B be like should B have to be some like an integer, or can it be a float? Can it be some other number? Any thoughts? Like can I do a power 2.3? Can I do that in Python?
Yes, can be anything.
Can be anything, right? So B can be, yes, correct. Can be float, integer, doesn't matter, right? Um, okay. Then what are the operations? Yeah. Uh, so to store sequences sort of data, correct? What types are available to store sequences or sequential data?
List,
Representation.
list is there.
Yes, one
Array,
is list.
array,
Uh, yeah.
array,
What else?
array.
Tuples. Yes. What else?
Sets.
Sets.
Dictionary,
Dictionary. Yes. What else? So you can also call string, right? String is also a sequence of special characters. I mean, a special type that is basically just the characters, right? Um, on the keyboard, whatever is possible, all those characters come as the possible values in a string, right? Um, who said DQ? What is DQ? What's DQ? Yeah, again, so q by default is not there in Python. These are all things that we can define on by ourselves, right? So basic types, which exist in Python to declare or to store sequential data, would be these, right? List, array, tuples, sets, dictionaries, and strings, right? um, so among these, which is which is mutable? Does anyone know?
List.
Let's go one by one. Yeah. So list is mutable. What else? Array is mutable or not? Actually, array is not completely covered here. So let's just leave that for now. Yeah. So let's go to tuples. Is a tuple a mutable quantity?
No.
Tuples you
No.
cannot, right? Sets. We can change set elements, correct? Dictionary. Yeah, somebody said string and tuple are the only ones which are immutable. Yeah, which are immutable, right? Others, everything is mutable, correct? Then what about different types of data? Like can a list contain different types of data in it?
Yes.
So unique data type elements, let's say, right? So list can contain, right, multiple different types. What about tuples? Let me just change the
It
question.
can have different things.
Yeah, right. So list can contain, tuples can also contain different types. Same thing with sets, right? Tuples can store one kind of data type. No, right? Tuples can store multiple kinds of data in them. It's just that again they have to be sort of um, yeah, no, they can store any kind of data type, right? Sets also same thing, right? Dictionary also same thing. Only strings cannot be. Strings can contain only special type, which is your strings in themselves, right? So characters basically, right? Okay. How do I, let's say, add element to a list?
Append operations, append.
Append.
Correct. Yeah, that's
List
good.
dot
So
append.
yes. So just a moment. Yeah. Let's say adding elements to a list. Somebody said, so let's say it's like this. Yeah. So list dot append. That's one way. What other ways we can use? We can do extend. That's correct. So when I have to extend, what kind of operator can be there? What kind of values can I pass in the extend function?
List items. Another list.
Only list.
And I extend, it is a list. Append,
But
it is only element.
yes, for extend, should I pass only lists? Can it be something else also? Can I pass a tuple here? Let's just check. So tuples are also possible, right? So in general speaking, it can be any kind of iterable. Like basically, you can pass it one by one, something which the Python can loop over, right? That's the idea in extent. Okay. Can I, so if I were to have, let's say, a string like this, let's say S is hello, and if I do L dot extend of hello, extend of S, sorry, what will be present in the list L now? Leave all of this. Let's not worry about all of this, right? If this is the function that you have, L is first an empty list, then I have S as a string here. Then if I say L dot extend of S, what will be in L? Anyone?
Will be list.
Yes, but what are the contents of this list? L.
Hello, element, one element.
It'll be one element as a string.
Yeah, I think so.
Anyone else have a different answer?
Single element HELL one character.
Correct. That's exactly what it will be, right? So it will basically loop over the elements in S, right? Which is HELLO, single elements. They will all become elements in the list L. Okay. Right. Yeah. How do we remove an element from the list? Let's say if this is a list, if you have to remove the letter E, how do I remove it?
L of 1 should be removed.
L of
1
Remove.
index.
L of 1, and then do what?
Dot remove.
Okay. So dot remove is there one option. L dot remove. Let's say if I give E, we'll come to the L of 1 example, just a moment. Yeah, so this removes E from here, right? If it finds it, it will remove it. Let's say if I give P here, it's going to throw an error in list. That's the thing that happens, right? So Karan, again, L dot replace will not work, right? Because L is now a list, right? If you have a string, right? If you want to remove the E, letter E from the string, then S dot, let's say if I do replace of E with empty string, right? And then print S here, for example, this will give me, for example, your, I will reassign it. Yeah. Yeah. So this will give you HLLO. Okay. So replace is a method for a string, not list. Yeah. L of 1 thing, for example, can I do del of L of 1? So what does del do, by the way? So print L here first, and then we'll see. So del basically deletes any that particular element from memory, right? In some sense. So here, the second element in memory, which is the second element in the list, that gets deleted, right? In this case, it is E, right? Which is what we want. Okay, fine. This is about removing from a list. Let's say if I have if I slice a list, right? How do I slice a list, by the way? If I want, let's say from second to fourth element, how do I slice this list?
L of square bracket 2 and then 4.
Yeah. So now let's say L is this one. Yes. Somebody's square bracket. Yes. So it's 2 comma 4, right? So this will basically give us this will give us second element and third element only. If we want the fourth element, we have to take the 5, right? This will give us the second, third, and fourth element. That is, sorry, third, fourth, and fifth element. That's right. You get 5, 6, 7. Okay, fine. If I were to give something like this, let's say, what does L colon 5 mean?
Starts from 0 and up to index 5 minus 1, that is 4.
That's correct, right? So in this case, it's this one only. Let's just change it. Yeah. So first, not first 4 elements, first 5 elements, right? So this is basically going to be saying that up till 5 index, right? That is 4 index. Therefore, and 4 index means 5 elements. That 0 is the first index, correct? And then if I do something like L of colon, just colon, no start, no end, this basically means take from start to the end. It's the same list elements, but this slicing gives us a different list altogether, correct? In memory, in a sense, correct? Okay. Then this is about slicing, removing, adding, and creation. Anyway, it's like this, straightforward. What about in strings? Let's move to strings. Oh, it's not showing up. Just a moment. Yeah. Can you guys see the screen now?
Yes, sir.
Okay, fine. Yeah. So let's say now if I have a string, same, let's say hello. Okay. Now, how do I slice a string? Let's say if I want only ELL, how do I get that? What do I write here? S of ELL I want as a result in this case. How would I do that? I don't know why Teams is behaving this way today again. S of 1 to 4. That's correct, right? So it'll be second element, then third element, fourth element. So you want the fourth element also. So the index we wanted to include is 3, and therefore we have to go until 4. Okay, this gives us ELL. Fine. How can I so can I change the string though? Can I change it to let's say if I have to change E to P, for example? How do I do that? Change E to P. So one is the replace option that we discussed, right? But can we change it in place? Can I change the string to the same string that we have here? No, right? I mean, correct. So that's the whole idea of mutability. That's basically you cannot change the string in place, right? So again, there are two ways of doing this. One would be your usual replace option, right? So this will give you a new string altogether. Let's say if I call it S2, right? And if I print of S2, right? This will give you HP LLO. Now, so it has a count option also. So let's say for example, if I want to change only the first L to something, correct? If I do this, this changes all the L, every L to P. If I give count as let's say 1, I think it is from the first occurrence. Oh, from the last occurrence. Okay. So first occurrence, yeah. So HEPLO, right? So the first occurrence will be changed to P, otherwise it will be left as it is, right? And if I do let's say some N, where N doesn't exist only in the string, right? This will leave the string unchanged. There's no error here. Okay. It's about in a way you're changing a string. Other thing, for example, was somebody had mentioned. I think somebody mentioned concatenation. So for that, how we can do is we'll say S of colon 1, right? This will give you the first element, correct? Then plus, let's say P, and then plus I can do S 0, 1, 2 colon, correct? This will basically give me another string which would contain what I wanted to do before, which is basically change the change E to P, right? Is one more way of doing it. Fine. Okay. So this plus is basically doing the concatenation of two strings into a new string, right? Let's say if I do this plus operation between two lists, what do I get? If I have 2, 3, let's say L2 is uh, 4 and 10. What does L plus L2 mean? What is L3 in this case? It makes a single list, that's correct. And it's doing what? Yeah. So it's exactly 2, 3, 4, and 10. So this is what you will get. That's basically concatenating two lists to form a new list, which which has all the elements of the two lists in them. Okay, in that order, by the way. That's important. Okay. Creation, adding, removing, slicing. How do I check whether a element is part of a list or not? Let's say I want to check whether 11 exists in this list. In L3. How do I do that?
In operator.
In operator. That's correct. So L11 in L3. That's it, right? So this tells you whether the element is present or not. It's a Boolean sort of it's a 1 or a 0 sort of a thing, right? So it will say 11 in L3 is false. That means it doesn't exist, and not in that basically will tell you whether it is not present, right? So in this case, it's true. So 11 is not in L3, which is a true statement. Okay, so in and not in, these are the two things that you can use to verify. What does difference between plus and extend? Okay, yeah, so extend will basically update the same list, no? um, yeah, so extend here, for example, will change the same list to have elements of the input list here, right? So in this case, for example, if I give L is an empty list and like this, so L gets updated to having those elements. Here, plus is basically a new list altogether, right? L plus L2 will give a completely new list. You can obviously assign it to L and then say, okay, it's just the new list altogether. That's the only difference here. No big changes in that sense. Okay. Extend allow only one argument. That's another point. That's true. Yeah, right. So you can only update one list, for example, let's say together. Here L plus, if you want to, I can do, for example, let's say multiple such lists now, right? And then all of those will get, have will have, let's say, a single. So you'll have one list which has all the elements of these individual lists. Okay. Fine. So then what did we have? Yeah. So what does this mean? Let's say if I have L is equal to L, sorry, 4 into 3. What does L contain now when I do this sort of operation here? Let's do 4 comma 2 into 3. If I do this, does it mean I'll have 12 comma 6 in L?
No. 4-2 will be repeated 3 times.
Right? That's exactly what it will be. So we'll have 4, 2, 4, 2, and so on as a single list. So Srinu, this is not going to be multiple lists, right? No. So it's not it's not sub lists. That is the case if the element inside this bracket was a list, only then. Otherwise, it's C. You can see here it's a single list. It's a single list having 6 elements, right? It is not a list of lists. Okay, I hope that's clear, right? So it's not like this 4 comma 2, then another bracket. It's not 3 sublists in it, right? That would be the case if you would have something like this, I think, yeah. So we'll have one element and then you'll have this one. That's correct, yeah. Right. So you would have now, this is the case, you will have 4, 2 as one list, and that is that is present 3 times, right? The other operation is very simplistic, right? It'll have 4, 2 repeated 3 times. Okay, fine. Hopefully this is clear. So this is your star operation. Yeah, this is a star operation. Plus operation is done. Yeah. So coming to nested list, which this exactly what in nested list looks like. So because I can see a list can have any kind of elements as its any type as its element. So it can have list also as its element in it, right? So hence, which is exactly why we can get things like nested lists as an option. Okay. Then, so strings we discussed. Slicing tuples. Yeah. How do I create a tuple? Let's say I want to create a tuple with these elements 3, 4, and 5 as the elements of a tuple. How do I do it?
Brackets.
Yes, which brackets? Round brackets, exactly, right? So 3, 4, 5, right? So this will give you basically a tuple which has 3 elements, 3, 4, 5. Now tuple again can have any possible type in it, correct? So let's say if I do T as 3, let's say a list 4, 5, and then let's say some string. This is also valid operation. Okay. It's also a valid operation, right? This is about tuples. Tuples you cannot change, right? So you cannot do something like, let's say T, how we did T dot append, T dot list dot append, list dot extend. We cannot do that because again tuples by definition are not mutable, right? So you cannot change them. So once you create a tuple, that's it. Okay. Then what do we have? Is yeah, dictionaries, right? So let's say how do I create a dictionary? Let's say I want to map values of, like, let's say 4 to hello and 5 to hi. How do I create this dictionary?
By using keys and parentheses.
I'm sorry.
By using keys and parentheses.
By using flower brackets, right? I hope that's what you're saying, right? So yeah, so 4 and then let's say 5 and hi. Okay. Now this is one way of doing it. You can also do something like this, which can say d is equal to dict of, right? This will make it even more. I mean, this is also clear only, but you can make it like this also. You can say 4 equal to hello, but that doesn't support that way, I think. Yeah. Let's say hello equal to 4 and hi equals to 5. Yeah. So this one does, so you can use things like this, but this will allow only your strings to be your keys, right? Whereas in dictionary you can have integers or strings as your keys, right? Can a tuple be a key in dictionary? Can I write something like this? Yes, tuples can be part of a dictionary, right? Can be a key in the dictionary, right? This is a valid argument, a valid thing to do, right? And again, the values which are stored against a key in the dictionary can be again of any type. right? They can be lists, they can be tuples, they can be dictionaries themselves, right? So let's say if I do something like this, this is a valid operation, right? And where I have something like, let's say, hello is 5 and is 6. Okay, so here I have dictionary D, which has a key D, right? A key K, for example, right? Whose value against that dictionary, that key K is a dictionary again. Okay, it's fine. Now, how do I access this key HHI? How do I access this key from this whole nested dictionary? Let's say I want to get this value 6, right? How do I get it? How can I get it? D2 dot key. No. I want the value 6 from the dictionary D, not D2. D. So how do we access elements in dictionary? D dot value. What will D dot value give? By the way, it's values, but yeah. So what is D dot values going to give us in this case?
Yeah. D dot K dot.
D dot K.
Yeah, dot K or that.
No,
Brackets K.
brackets K, right? It's going to be square brackets K. This is going to give me this whole dictionary, right? Because that's the value stored against the string K, and then that's again a dictionary. So I will again have to use a of again HHI, right? This will give me the value K. Sorry, 6, value 6 stored against HHI. Is that clear? Right? So you access dictionaries which are in this way nested in this format. Okay, same like if you were to go into access nested lists, right? For example, if I have a list something like this, 5 comma 6, and then let's say 9
బట్టలు దీవా అపూర్వ
11.
వర్షం పడుతుందమ్మా
Ravi, can you please mute yourself?
బాల్కనీలో బట్టలు దీవా.
Okay, so now what do I have? I have, let's say, if you want to access the value 11, right? Then in this case, 11 is a third element in this list, and this list is a third element in the outside list, the L list, right? So it's going to be L of 2 of 2, right? So okay, so this gives us 11. In the same way, we're going to do basically for the dictionary also. So when you have a nested dictionary, you will basically end up accessing it like this. By the way, what does d dot values give? In general, I mean, what is dot values function going to give you for a dictionary? So it's it will give all the values against all the keys, right? And there's no ordering that would be present, right? So though let's say you might get order now every now and then, it's not guaranteed to give you that way. Okay, so here if I do print of d dot values, right? So you can see here it's hello, hi there, and then this whole dictionary is a value against the key K. That's how we are getting the whole dictionary here. Okay, fine. This is your dictionary sort of a thing. Then what else? Yeah. What about a set? How do you declare a set? How do you add elements to a set? How do you remove element in a set? So first of all, let's if I want to create a set now, how do I do that? Set of elements, let's say 3, 4, and 5. It's simple again. Yeah, right. Set of, if I want to now make it make the elements 3, 4, and 5 in this set, how do I give that? So this set is an empty set, right? This set is an empty set, right? Now if I give, let's say 3, 4, and 5, this gives me the set which has the elements 3, 4, and 5 in it, right? This is one way of doing it, or you can do it like this: 3, 4, and 5. Okay, it's the same thing. Okay. So again, remember, this flower brackets is used for both dictionaries and sets. Okay, but in set you will not have anything stored against that value. It's not a key value pair, right? And therefore, in general, when let's say if you write, let's say some you as just a clean cut, I mean, just open and close the flower brace. This is basically understood as a. Anyone want to take a guess? What is U? Is U a dictionary or a set now? What does Python think of it as? A dictionary. That's correct, right? So it will take it as a dictionary. Okay, so by default it's dictionary, and then if you provide something like this, so where it helps Python disambiguate what it exactly is, and then it's okay, it's a set. Fine. How do I add an element to a set? Let's say I want to add the number 6 to it. How to do that? Append. Is there an append option in set? So again, remember, append and all is basically in the sense of a sequence, right? Whereas here it's not a sequence. There is no order associated with a set, right? A set is a collection of unordered items, right? What do you do for a collection of unordered items? I mean, so s dot add. It's as simple as that, right? So you want to add an element in the set, you just say s dot add, let's say of 6, right? And if you were to do this, you will see we are at 6 to this particular set. Okay. How do I remove? Let's say after adding, I want to remove the element. Remove 6 from this set. How can I remove the element? S dot del, no. Discard, remove. So s dot remove. Oh, s dot remove is there. Let's see what happens. Yeah, so removes it. Okay. I think remove has a remove doesn't have, yeah, correct. So remove, for example, if you try, if the element exists in that set, it will remove it. If it doesn't exist, it will basically give a key error. Fine. Any other options exist? Somebody said pop, that's correct. But s dot pop is basically what it will give you. Print s dot pop, right? So this will give you, let's say, one element from this one, right? From the S set, right? So not exactly sure what element you're going to get. Okay. But you can see here, right? For example, let's say 3, 4, 5, 6 was there. 3 was popped out from the set, and then you got 4, 5, 6. Okay. And there's another option called as s dot discard. I think this was not, I don't know if it is discussed or not. Yeah, s dot discard of 6. This basically removes the element also. But let's say if the element does not exist in the set, it will not throw an error to you, right? So remove and discard, both do very similar operations. All right. But the idea is one throws an error if the value doesn't exist and the other does not. Okay, fine. Okay, this is all about, let's say, your data types and all of that stuff, right? Let's come to control structures. How do I do a simple condition-based execution of a code? What is the construct to use if I want to do conditional execution of some code? If else.
If condition.
Correct.
Black
If,
statements.
right? So if condition, then you'll have something to do here, else you'll have something to do here. Correct?
Yes.
Condition is some value, true, false, or whatever, right? Um, for multiple condition checks, what can I do? If, that's correct. So if I do if condition, then let's say some work here, and then say elif condition, let's say, right? Some other thing here, and I can do multiple of these elifs, by the way. Any number is fine. And then finally, I can or cannot have else, right? There is no compulsion that it should have else. There's no compulsion it should have else here also, by the way, right? So this is the idea. So if else is for doing one operation or not, or the other, let's say. Else if is basically to check multiple different conditions. Okay. Um, uh, what are two ways of doing looping that you guys know about?
For and while.
For and
For
while.
while.
Yes. So let's say you have L is some list, to for and all that, right? So if I do for I in L, right, print of L, this is going to print all the elements in the list L one by one. Okay. Now if I do so when is while useful versus for? So while versus for. Any thoughts when you?
Yeah, we don't know how many number of times it needs to execute until a condition becomes false. What are
Until
our
it false.
yeah.
That's correct. Right. Yeah. So you will do while when you have no idea how many times you want to execute some part of the code, right? And it depends on some condition, right, which may or may not change during the execution of the loop, right? That is basically the use of while. And for is basically more useful when you know how many times you want to do. Like, you have a fixed set of things to go through, then you can use for loop. Okay. Yeah. Oh, before that, yeah. Okay. So this is about the one sort of control structures. Um, yeah. Um, how many? So okay. So uh, how do we define a function in Python?
Just
Using the def
define
operator.
F
Def,
block
right?
of statements. Yes.
Correct. And then what follows is the function name. That's correct. Somebody said function name. Yes, correct. Right. Function. And then you have a closing, opening and closing round brackets, then a colon, and then the function definition starts. What you want to do in the function. Correct. Right. What can be the yeah? So parameters that you have in the function. Let's say if I have a comma b, right? What types can A and B be? Any you know uh, problems if A and B are any unknown types, something like that? Is there is there a constraint on what type A and B can be? Like should A and B be integers always or strings or this one? No, right? In fact, in fact, can B be a function itself? Can the parameters be functions themselves? Somebody said no. I don't know. Huh. So, so the parameters can themselves be functions, right? So let's say, for example, here, if I define it like this, a and then function one, right? Fn1 is just a parameter name, right? And then I do something like this. Let's say fn1 of a. I operate a on fn1, right? And then I multiply that by 2 and say return this now, right? So if I have, for example, if I define a function, a different function, let's say f2, okay, which takes me one parameter, let's say call it x, and I returns the square of this guy, right? So then I can call fn of let's say 3 comma f2, correct? What will this return me, by the way, if I do this? Fn of a, that is a is given as 3 and fn1 is given as f2, which is a sorry, function name, right? What will this be, the output? 18, right? Very simple. So because first of all, you'll have this function executed. In this, you'll have fn1 of a, which is basically f2 of a, right? So f2 of a, this is going to give you 3 squared, that's 9, and 9, then this becomes 9. 9 into 2 is 18. Fine. So this you can pass functions itself as parameters. How can I? So if I don't want to pass a parameter in this function call, let's say, right? If I have, let's say, multiple parameters, let's say I'll define a new function now, f3 of a, b, and c, and I'm doing something with them. Let's just print for now. Print a, b, and c. Yeah. If I do this, how can I let Python know that, okay, if I don't give the value c, you can just go ahead and use some other value, some default value? How do I give that information to Python? Any thoughts? C is equal to something, correct? So if I give C equals to, let's say, 3, for example, yeah, this is the idea of default arguments, correct? So if I give C is equal to 3, for example, if I call f3 of 2 comma 10, right? This is going to print 2, 10, and 3, right? So this will make sure that if C is not provided, Python will use the value 3 as the value for C. If it is provided, for example, then it will just use whatever you have given. Okay, if I give a 4 here, it's going to give 2, 10, and 4. Okay, and yes, this parameter has to be at the end, right? So default arguments cannot occur in between the parameter list, right? So I cannot have a function definition which goes like this. Let's say f4, if I do b equal to 3 and then c, this won't work, right? You can see here that there is some function definition problem, correct? So non-default argument cannot follow the default arguments. Fine. And you can have
Excuse me, sir.
any number of default arguments, by the way. You can have like d equal to 6 or something like that, and so on and so forth. Yeah, somebody had a doubt?
Sir, during the exam, do we get the programming questions too?
I'm not sure. I don't know about the program, the exam pattern and all of that.
Okay, sir. Thank you.
Okay. Yeah, so I can have these default arguments. Then yeah, so now let's come to, let's say, if the argument is mutable in the first place, right? Let's say this is the part that was, let's say if I have function f4, okay, and I pass a list to it, and if I say L of 2 equals to 10, and that's it, nothing else to do here. And if I say I'll define a new list, let's say Ln is a list 3, 5, 6, 8. Let's close this for now. Yeah. if I do this, what will happen if I after the function call f4 of ln? Yeah. If I print ln, will ln remain unchanged, or will there be a change in this list ln? Unchanged, immutable. What is immutable? Is list immutable? Because there's no.
It will change to 10.
It
L2,
is 10,
second
right? So
element will be 10.
on the money, right? So for example, so what will happen here is this will end up changing the list third element to 10. Can anyone tell me why this is happening? Somebody made a very good point of that there's no return statement, but then how could this be happening?
It is a location, it is shared. Location is updated. So that memory location is updated. Var parameter. It is like, value parameter and var parameter. This is a var parameter example. Like in Pascal, we have value parameters, var parameters. This comes
Oh,
under var parameter.
okay.
Means conceptually.
Okay, so I don't know the var parameter in Pascal, but your point is right? So here what we are passing, so what gets passed around from this f4 function is basically the location, the pointer to this list, right? So ln basically is a representation of the location where this list is present. So then when the location is passed to this particular function, right? So we're saying in that location, the third element you change to 10, right? So that is what exactly happens in this case, right? So hence the list changes its value because of this sort of a work, the way the Python is works. Okay. So be very careful when you're using mutable arguments, and you're changing their values inside the function. Okay, unless you know for a fact what's happening, don't you might be doing something weird also. Okay, fine. Slicing happen. Yeah, slicing will happen, right? Because I mean, in the sense what, like because L is a list now, right? So all things that can be done with a list, which is slicing and other things, you can do it, right? No problem. I can do even, I think let's L dot extend. If I do 3, 4, that's fine. So, right. So if I do this, so again, L is again pointing to that location, right? So that list gets updated, right? With this extending operation also. Fine. Once give ln as L, matlab, I am giving ln as L, right? So when I call, that's the argument that it uses. Okay. Wow, this reminds me. So during calling of a function, right? So even there's Python allows some additional stuff. Let's say I want to provide. So here what happens is if I give 2, 10, and 4 in this case, for example, if I have a function like this, right? A, B, C, and I'm just printing A, B, and C. If I provide the values 2, 10, and 4 continuously, it takes the first value to be A, second value to be B, and third value to be C, right? What if I want to interchange the arguments? I want to provide 10 first, but 10 should belong, I mean, 10 should be assigned to B, but I want to give 10 first. How do I do that? Any thoughts? So this is more on the lines of the function calling, right? So we have discussed function definition. How do you call the function in different ways?
Yeah, since you are specifying, B10, that you can specify before.
Mm.
So then it will understand that B is for that second parameter.
Right. And so this is your positional arguments,
Position.
right? I mean, you're giving the arguments based on the position that exists in the function definition. This is more of a keyword argument, right? So you're giving what the parameter name is in the function, what value it should take, right? And both of them have this, a bit more easier to understand in the sense because you know exactly which parameter is taking which value, right? That's the idea. So you can do b is equal to 10, a is equal to 2 in this way, and then c is equal to 4, right? This will be the same exact thing that was happening before, right? Do it, fine. So you can call it multiple different ways also for a function, right? Can a function call itself? Can a function call itself?
Yeah, that is what is recursion.
That's exactly what recursion is, right? So so yeah, so let's say if I want to solve the factorial problem, right, where I have n equal to n factorial, I want to compute, right? So how would I define this function? Let's say fact of n, correct? What do I return? How can I compute a factorial in using recursion?
Yeah, factorial 0 equal to 1 and n into n minus 1 factorial.
So we use a recursive inductive definition for the factorial function, right? Which says that if you want n factorial, it's same as computing the n minus 1 factorial and then multiplying with n. Okay, so in this way we can do that. So it's going to become n into fact of n minus 1, right? But again, you need this to stop somewhere, which is also a part of how the inductive definition goes, which is basically saying that if n is let's say 0, that is 0 factorial, for example, is set to 1, right? So that part also we basically take here. We say if n is equal to 0, we just end up returning 1, right? So in this case, so in this way we can see very simply write inductive definition based algorithms in terms of recursive functions. Okay, this one idea. Yeah, we can do n less than or equal to 1. Anything is fine. I mean, that's all those variants are fine. Not a problem, right? Okay. Yeah, let's go to let's talk about a map and filter, right? If I want to, let's say if I have a list, L is equal to 2, 3, 6. If I want another list which has the square of all the elements in this, how do I do that? And as a list, I want the output as a list. Okay, so how can I do that? Any thoughts? For I in L, that's correct.
Lambda function. Lambda.
We'll get to lambda. So I squared, right? This is basically your squaring of the element, right? And now you want to store this in a list somewhere, right? So for that, what we'll do is we'll create another list. Let's say SQL. That's basically your square list, right? And then we keep on appending the elements into this. Correct. So you will see that you will get you'll end up getting your getting your each element ka square, right? This is in a usual way. if I have to use, let's say, map operation, how can I use the map operation to achieve the same thing? Map operation to achieve the same thing. How will you define the code? So what all is required to write the map function? What things do we need? Map.split. What are we splitting? Map function and then dot split, but what are we splitting here? Why do we need that? So map function basically takes in 2 arguments, correct? Takes in 2 arguments, right? So one is what function you want to apply on the elements of the list, which of an iterable, which is the second argument, right? So in this case, what I want to do is I want to do the squaring, but on which elements? Here in the elements in L, correct? So that's what I provide the second argument as L. The first argument needs to be a function that you want to apply on each and every element, right? So there are 2 ways of doing that also, by the way, right? So what I can do is I can define a function, let's say sq square, which takes in some x, right, and returns x square. Very simple, correct? So then what I will do that is I will say, I'll just give the function name here, right? So map will basically end up doing the this whole process that we have, basically going through each and every element in that list, right? And it will give you an output in terms of an iterable. We want it as a list, so what we'll do is we'll say list of map of this. Okay, is that clear? This will give you the square list now, SQL. Okay, is that clear? The another way of providing this function is this is basically I mean, see, if you have a very simplistic function, you can use a lambda functions to define what the function is. Okay, so I can say SQL as list of map of 2 arguments. Second argument is L, right? And then say lambda x squared, right? So if I have so when you have things like this, lambda x squared, this means it's a function which takes in 1 argument, that is x, and returns the square of x, which is exactly what this function is. Fine, is that clear? And it provides the same thing here for you. Okay, let's say I want the square of elements which are square of only the even elements. How do I achieve that? So I have a list of elements, right? So only those elements which are even, right? Even and odd, right? Which are even. Only those elements I want the square of those elements in my output list. And mod equal 2 is equal to 0 is equal to 0. That's correct. So how would you do that in this case? So let's say if I were to do that, square of all even elements, correct? So I'll so this condition will come where, by the way? Somebody did another operation. That's correct. Okay, we'll come to that. So if I mod 2 equal to 0, correct. So this basically tells you that you go over the elements in the list L. If it is even, only then you append it to the output list. Okay, so that's basically 4 and 36. Correct. Can I do this using map and filter? How do I do this using map and filter? Does anyone know what filter is? Filtering is basically what the name suggests. It will choose elements in the list to do something, right, based on some condition. Okay, so in this case, what I can do is I can say map of. Again, map needs 2 arguments. First argument is basically what you want to do with the element, right? In this case, what you want to do is basically just square it, right? So we'll do the lambda function, for example, lambda x squared, right? But second argument will not be L in this case, right? Because we want to do it only for those elements which are even in nature. So for that, what we'll use filter, right? So filter again takes 2 arguments, right? First is what condition should you filter on, right? So if the condition is true, then it will be considered in the forward process. Otherwise, it won't be considered, right? So what's the condition? The condition is basically whether it is even or odd. So I'll use x mod 2 equal to 0, right? So in filter, the output has to be a boolean in some sense, right? So if it's if this is true, then the element will be considered forward, otherwise it won't be, right? Again, filter needs same 2 arguments. One is a function and one is a list on which you want to filter. So in this case, it will be L. Okay, this is the final output that we will get. Finally, we'll use list so that we get the output. Okay, printed. So 4 and 36. Fine. Is everyone clear on how this worked? How we are using map and filter combination to be able to do something a bit more complex. Okay, fine. This is your map and filter. Yeah, so somebody mentioned on another idea, right? So which is your list comprehensions. So how can we do it using, how can we do this same things using list comprehensions? Let's just look at that, right? So same thing here. Let's say if I want SQL, for example, I just want to square of all the elements in the list L here. Okay. So using list comprehension, what you can do? So I can write for I in L. So this is the iteration part of it, correct? And then what I want the output to contain, right? The list to contain, that operation you will write here. That's basically I square. Okay, so this gives you the elements, each element ka square. This is what you're printing here, right? So every element gets squared in this format. Okay, and if I want to achieve this sort of an idea, which is basically square of only the even elements in the list in L as a list, right? So then what we'll do, again using list comprehension, if you have to try, this basically is going to be P is equal to, anyone want to take a guess? Correct. So it's going to be X, or let's say, X. Fine. So for X in L, this is the iteration part of the part of the thing. And what you want to do, the operation is X squared, right? That is your X square. And but you want to do this only for if X is even, right? So that condition comes up here. If X mod 2 equal to 0. Okay. So see, just try to look at how different things are coming are being placed in different places, and why it makes sense to Python for doing it that way, right? So this example will help you understand that. Okay. Okay, so here we have the first the looping part, then the condition, and then you have the appending part, which is what makes the most sense to any human, right? Map and filter allow you to do that in a bit more in a different way, right? So where you say, okay, you first filter out all the elements which are even, and then you can do the squaring on top of it. Okay, and this list comprehension is a different way of doing the same thing, right? Which is basically saying for x in L, let's not use x, we'll use I only again. It's easier to compare. Okay, so if I mod 2 equal to 0, that's the condition, and this is the looping part, and what you want to do with the element that you will put it here. Okay, map and filter. Okay, we'll do that in a bit once again. So we can write name is equal to arithmetic operation iteration condition for list compression. That's correct. That's exactly correct, right? So what operation you want to do, it need not be arithmetic operation. In sense, it can be any function call. For example, function of I. No problem. Correct. So we can define some function here. Okay. Does that make sense? So any function, basically anything that you want to do more complicated with the element can come up here. But this is the looping part. That's your iteration part, and then the condition. This is for your condition based list comprehension. If there's no condition, for example, you can just omit this, right? Which is what we did here, right? So where you can write again this as like this, right? So you just have the operation and then the iteration part of it. Okay. Yeah, so somebody said the list and map and filter is not clear. See what we're doing here. Again, filter takes in two arguments as input, right? The first argument is basically telling you a condition based approach, right? So where it says that okay, if that function is true, right, then it will consider that element for any future operation that you want to do, right? Otherwise it won't. So in this case, what we're saying is you consider the element if the element is even. That is this function, right? And it operates on this particular list that we have. Okay. Then map tells you whatever element you have, what you want to do with that element, right? That's basically squaring in our case. Fine. Okay. So hence, so first you filter out basically elements in the list, whether it's even or odd, and then you get the squaring. Okay, is that a bit clearer, Durga Tejasri? Okay, so this is your list comprehension map filter. Okay, fine. So now that we know how to write loop, how to do all of that, yeah. Let's say I want to do very simple searching operation. Okay. What is the how would you go about doing it? Let's say I'll define a function now. Yeah. So search, I'll define a function called search, right? I'll provide the first as a list of elements in it, and I want you to search the value v in it, right? How can we search for this? Now you know what looping is, you know condition based stuff, you know how to define a function, right? Very simplistic sort of a thing here. Let's quickly go ahead with this. search for if V in L, that's correct. Yeah, this is in case you're dealing with Python and it allows you to do something like this, correct? But in case it's an unsorted array, right? Where you cannot do like a member check sort of a thing. How would you go about doing it? Yeah, it's unsorted. That's correct. It's unsorted. So hence the only way to do it is linear search, right? So how will you go about doing it? You have to keep on iterating one element over the other, right? So let's say for I in L, right? And then you'll check if I equals to V, correct? If it is present, right? Then you will say return true. Fine, that it is present, right? In case it's not present, you'll say return false. Fine, very simple, very simplistic search operation, right? It's a linear search, right? Where can we apply binary search, by the way? In what condition can I apply binary search anytime and every time I want? It's very efficient, right? So why not apply
Already
it?
sorted. If it is already sorted, you can apply.
That's it, right? So binary search is only possible if it is a sorted list. Correct. Now, so let's just go very quickly over the algorithm that binary search does. Let's say I have a sorted array. Okay. So I'm giving you a sorted list here. Right. What is the idea of binary search? The first thing that you would compare, let's say I have a value V, I have list L. Yes, the mid value, right? So you'll compare first this V with the mid value, right? And how do you get the mid value, by the way? Mid index. You need the mid index, right? So what's the mid index going to be? L plus R by 2, right? So it's just going to be first and last by 2. That's correct, right? So in this case, so binary search, for example, right? If I have a list and I will give, yeah, let's say the array L, left, right, and what value we want, let's say V, correct? Yeah, length of L by 2 will work for the first time, right? But again, we want to do a recursion sort of an approach. Yeah, I didn't make that clear before, but the idea is that I can check basically with the first the mid value that is present. If it is not found, if it is not same, then because the list is sorted, right, I can now make a clear guess where it could be present, right? So if V is less than this value, then check only in this part, right? If V is less than the mid value, if V is greater than the mid value, then it's more likely to be present on the right side of the list, right? And so then what happens is it becomes a simpler or a smaller version of the same problem, right? So we are now again searching this V element in this part, right? We're searching the V element in this part, and this part is also again sorted only, right? So hence you can break down this binary search problem as a smaller version of the same problem. Okay, fine. So in this case, basically what you will do is you'll say return binary search. Sorry. So here you will say if, let's say mid, for example, you will compute it as left plus right by 2. Again, not exactly this one, but you can just check. So if V is equal to what the value is at mid, correct, then you're done, right? Return true, correct. And if not, then you will do, I can do elif here, correct? V less than L of mid. I have to search the left side of the array. So then you can just say return binary search of the same list, but now you will search from whatever was the left element up till mid minus 1 with the same value, right? And then else here would be the other side of it, correct? Mid plus 1 and then to the right. Okay, simple. And again, here you have a base case here because you will say in case it's not found. So you will say if left and right are I mean, there's no array left to search, right? Then you will just end up saying it's not present. Okay, is that clear? Fine. This binary search algorithm. Fine. Now let's come to sorting algorithms. So hence see, so searching becomes easier if you can sort in a cleaner way. So hence you want to look for more efficient sorting algorithms, right? So anyone want to tell me what selection sort, the idea behind selection sort is? Lowest value. Correct. Lowest value. What will do with lowest value? Select the minimum element and then yes. So we will know exactly what position the element has to be present in. Correct. So let's say if I have an unsorted array, unsorted list, for example, right? So if you have the least value, right? Least value has to be present at the first location or index 0. Right? Index is equal to 0 will be reserved for the least value. Second minimum or second least value, right? That will be in the second location, right? Which is index 1. So this is the idea, right? So first what you do is you will say you find the minimum in this whole array. Wherever you found it, you just swap the elements. Let's say you found it here in the first run, okay? Then you will just end up swapping this guy and this guy, whatever is present here and here, right? So now what happened is this part of the list is clear. This the first element has the lowest value. Now again repeat the same exercise. Find the lowest value in this part, that is the remaining of the list, right? And put it in the first location of this part, which is your second location in the original this one. Right? Let's say you found it here, then you will end up exchanging these two, right? And so on. Things you continue. Fine. This is your selection sort. Now, what is the idea behind insertion sort? Insertion sort. Anyone? Add it to the list and sort the entire list. No. No. See, you want to sort, but again you say add the element and then sort means what do you mean by that? There is a very, I mean, the base case has something very interesting in insertion sort. See, the idea here is that correct. First element is sorted, right? So if you consider, let's say, a list of n elements, if you consider the first element as a list by itself, it is sorted by itself, right? Now what you will say is, okay, so now if you have a sorted list, where should my current element, let's say, for example, if you're looking at the second element, where should this element go in a sorted list? That is the key. Okay, so I already have a sorted list. What is the right position for my current element to go in this sorted list, right? So once you do that, then you will have this whole part. That is, this will become the new sorted list, so called, right? And now you look for the right position for the third element, and so on and so forth. So you will pick one element and you insert it at the right position in a already sorted array. That's the idea in insertion sort. Okay, is that clear? Then what is the time analysis of selection and insertion sort? Uh, Basically, what is the order of, yeah, is order of n square, right? Where n is the number of elements present in the list. right? So both of them are order of n square algorithms. Which algorithm can have a lower running time for these two, compared to these two? A. Selection sort is order of n square. Yeah, somebody said quick sort. That's correct. Any other algorithms that you know which can be used for sorting, which have lower running time compared to this? Yeah, merge sort. Any other? Merge sort, quick sort. There's one which was A. No, bubble sort is no. Bubble sort is also n square only. Yeah, shell sort. Yeah, many people know many things. Yeah, fine. Heap sort. Yes. So heap sort was also covered as, again, in passing in the lectures, but heap sort is also another as a sorting algorithm. So all of these have order of, what is their order? Is it n square? Is it n power half? What is it? Yeah, shell sort is not present in the lectures. It won't be asked. Don't worry about it. Yeah. Quick sort, merge sort, heap sort was covered. So you just worry about, well, think about that. Yeah. So it's not order of n. So there's no order of n sorting algorithm currently. So n log n. N log n is correct, right? So it's order of n log n. Now let's very quickly go for merge sort. What is the idea behind merge sort? The key point behind merge sort is what? Yes, divide and conquer, but in what way?
Linear.
Linear in terms of what is linear?
In terms of size.
Array. I mean, what operation is linear? You have, okay. So merge sort mein, what do? We basically, correct, merge two sorted arrays. That is the key point, right? So if you have already two sorted arrays, for merging those two arrays, it will be order of n operation. It's a linear operation, right? So the idea is that if you consider, let's say, whatever you want to sort as one big list, and you break it down into multiple lists, and then try to merge these sorted lists by themselves, then that will be a linear operation. Okay, so that's the idea. So then here in this, what do? Very simple. Let's say if you have a list like this, you will break it down into two parts. You ask the merge sort algorithm to sort this and then sort this, right? And then the merging operation will basically be a linear operation. Okay. Uh, yeah. So let's say you get a sorted array like this. Let me just use some. Yeah. For example, let's say this is sorted. Sorted one, sorted two, right? And then this this merging operation of two sorted arrays, this will take basically just a linear operation. This will be a simpler. This one will get a sorted array here. Okay. What is the base case in this sort of a scenario? So in sorting, generally the base case is very straightforward. So we can do this again in a recursive way, right? So we can say sort the left one, sort the right one, and then merge, right? So we can keep doing this keep breaking the list into small parts. Where do you end? Where will you stop this breaking? Any thoughts?
When you get single element, you will stop.
That is it, right? Single element, right? So in sorting, remember, generally speaking, your base case is just going to be when you have a single element, right? So single element lists are sorted by themselves, right? Single element list is sorted. This is the key, right? This is also, I mean, the point in insertion short, right? Same thing in merge sort also. Fine. Then what do we? Okay, this is about merge sort. Quick sort. What is the idea behind quick sort? See, I'm not going through all the programs and all that. I mean, that's not going to. It's going to
We
take
are
too much.
going to select the pivot element as a first element or a middle element or the end element. In the way you are going to divide and conquer and add them.
No, so selecting the pivot element is fine. What do you do with the pivot element? What is the operation that you want to do?
Pivot element must be middle of the greater than and the less than member set.
That's correct, right? So let's say you have a list of values here, correct? Okay, and let's say this is the pivot element that you are choosing. Let's say the first element here is a pivot, right? The idea is you will change the rest of the array in such a way that all the values which are less than this pivot element p will occur in one part, right? These are the values less than p, and values which are greater than p will occur in this part. Let's say the next part, whatever is here. Fine. So once you do that, now it becomes very clear where P should come, right? So P has to come exactly on this location, right? And by swapping the pivot element with the last element of the less than array, you will basically get the pivot element in its right position, in its exact position that it should be in. Right? So P is going to be here. And now what you will have is you will have a, see, in merge sort, we had two sorted arrays and we were merging them. But here, this particular part of the array is still unsorted, by the way, right? Even this unsorted. Okay. But one thing that you know for a fact is that these elements are greater than, less than P on the left, and on the right, it's, greater than P, right? So you will then say you run quicksort on the left part and the right part. Same algorithm, you will run it again, right? That's the idea behind quicksort. What is the worst case time compressor? Somebody mentioned you can take the first element or the mid element or the last element as pivot. What is the worst case running time? Remember, this is a bit different from usual ones. Correct. Worst case uh, time is basically n square, right? Basically, when it's already sorted in reverse order or something like that, then you'll have order of n square. And this does not depend on whether you choose the first element or the mid element or all of that, right? This is same for all pivot elements, either first or mid or last. Regardless of this uh, issue remains in some sense, right? So when you say order of n log n for quicksort, where is that coming from then? Any thoughts? So the order of n log n in quicksort comes from a average running case, basically average uh, case. So in this, the average case is basically computed over all possible permutations of a particular list, right? So where you say that, okay, if the list can be any which way it can, then on average I will look at, let's say, how much time, how much roughly that time is taking in each of these cases. Then you will take on the average, you will get order of n log n, right? Because it performs very well when you have a unsorted array, right? And the probability that you will get a sorted array as your input to do sorting will be very, very less, right? So hence this order of n square that you're seeing will get a very less weightage when you're trying to do let's say average case scenario. Okay, so this is your order of n log n for your average case scenario in quicksort. Fine. Yeah, we'll get to the heap sort in a bit. Yeah, so merge sort and quick sort. Let's say if I had to compare, correct? So merge sort, quick sort. Does anyone know which of these two is more stable? Does anyone know what's
Merge sort is stable. Quicksort is unstable.
Quicksort is unstable, merge sort is stable, right? So quicksort basically ends up shifting elements here and there. So it's possible that you lose the original ordering that the elements should have had, right? That's the idea behind stability. And memory requirement. Which one has higher memory requirement between merge sort and quicksort? Higher is for merge sort, correct? Because this creates a new array altogether, always, right? It creates a new list, and that it will basically, so that will have the elements from both the sorted list. So your merging operation requires you to create a list of the size that is present in the both the lists, right? And then basically fill in that list one by one, right? So hence it requires higher memory compared to quicksort. Right? This is lower, this is higher. Fine. Okay. So this is about the sorting algorithms. All of them have, insertion sort and selection sort is n square, and remaining are all n log n. Fine. So okay, let's do heaps and all of that first. Then we'll get into other remaining things. We have so much time only. Okay. So what is the idea behind a heap? Let's say a max heap if you have. How is a heap defined, by the way? What is the local rule that any heap elements should obey for a max heap? Right. The head node has to be maximum compared to what?
Child nodes.
The child nodes. That's it, right? So basically, let's say if you have a tree structure like this, for example, right? So the idea is whatever is present on the let's say the root, it has to be greater than both the child nodes. That's it, right? There need not be any specific ordering between the two child nodes, by the way. That is not required, correct? Only that, let's say if you have a parent and you have two children, the parent has to be should have a higher value compared to its children, right? That's all it needs. So parent should be greater than both children. That's the local rule that any element in the heap should obey. Now, by default, when you keep on doing this sort of a thing, the value which is the largest in among all the values will end up coming on the root, right? So the root in a heap, right? Because of this particular local rule, so the root will basically be the max of all elements. Max of all elements. Fine. Now let's say if I have this as a heap. Okay, how do we represent a heap, by the way? Do we need a tree structure to represent a heap? Any thoughts? Right, just the array is enough, right? So if we have a list or an array basically, so we can represent the heap in that way, right? So because the idea is you fill in this sort of this tree that you are seeing here one by one for every level, right? So first the root, and then the left child, the right child, and so on and so forth. So hence you can represent that as a array, right? So let's say if I have a heap which is something like this: 23, 10, 12, right? 4 and 6 and 11. Yeah, let's just do that. Yeah, 4, 6 and 11, right? So you can represent this heap as a contiguous elements, which is basically in this case 23, then 10, 12, 4, 6 and 11. Fine. So let's say your let's say some parent index if you have, okay, in this setting, what is the index of the left child? How do you get the index of the left child from the parent index? Parent into I. I is what? Any parent. I'm not asking the left child of the root. Okay. I'm asking, let's say if I have a parent index of, let's say, some P, right? Parent P, right? What is the index of the left child of that parent? See, because again, remember, all of this is basically in a way, ordered in some way here, right? So here 23 is the root, and then its left child is 10, right child is 12. Correct? Same thing again, you will continue. You'll say left child of 10 is 4 and right child is 6. Again, left child of 12 is 11 and so on. Correct? So I want to be able to go from parent to the left child, right? And right child, for example, right? So how do we get that? So left child is going to be, yes. So left child is going to be 2 into parent index. Let's say I'll call it P. 2 into P plus 1. This will give you the left child, right? Again, see very clearly. 23 will be 0. 10 will be 1. Okay. So let's just write the indexes here. So 0, 1, 2, 3, 4, and 5. Right? So 2 into 0 plus 1 is this one. This is correct, right? And if I say 12 ka left child is 5, right? So 2 into 2, 4 plus 1 is 5. 10 ka left child is 4, which is 2 into 1 plus 1. Okay. And what is the right child? Right child should be very, very simple from this now. If I know the left child, the right child will be left plus 1. That's it, right? Left plus 1. Or you can write 2 into P plus 2. Fine. Okay. So this is the thing between left and right child. Now, how do I get the parent index from the left and the right child index? Let's say there's a left index. Left child index is L. What is the index of its parent? How would we get that? And just invert this idea, right? Invert this 2P plus 1 sort of a thing. That's it, right? So this is going to be P will be basically left minus 1 by 2. Correct? Again, remember, left will always be an odd number by construction here, right? 2 into P plus 1 is going to be always an odd number, right? So L minus 1 by 2 will always give you a valid integer, right? It won't be like half or 0.1 or something like that, right? Same thing with right child. If I have, let's say if right is R, you'll get P as R minus 2 by 2. Same thing, just invert the equation that we have here, right? Now, all of this is necessary because we want to be able to, let's say, insert and delete elements in the heap, right? Let's say I have this heap, which is 23, 10, 12, 4, 6, and 11, right? If I want to add an element, let's say I want to add 28 in this heap, right? What would I do is first, I'll just go through it so that we can finish it off. So I'll add 28 here first, right? So basically we'll say that whatever element is place is present, we'll add 28 there first, and then look at whether that local heap property that we have, that the parent has to be greater than both the children, is it satisfied or not? right? If it is not satisfied, we just exchange that value with the particular root, with the particular parent, right? So now in this case, we just check whether 28 and 12 are, yeah. So in this case, we have 12 is less than 28. So which basically goes against the heap property, right? So we'll now exchange them, right? So this will give rise to a heap which looks like this: 23, 10, 4, and 6 here, and then 28 here, 11 here, and then 12 here. Okay, 12 is now changed here. Now again, we will check between 28 and 23, right? So here, what we need basically is we want to be able to know what is the parent index, right? Which I need to compare with. That's the idea. So you know the index of the child. You want to be able to compare with the whether what the parent index is, and therefore we need that reverse mapping, right? And then again check here, right, between these two values. Again, as very clear, this will basically end up becoming the root node. Okay, 4 and 6, and then you will have 23 on the right side now, and then 11, and then 2. Okay, so now this is basically a valid heap, right? We have given 28 properly in this. Now if I want to delete max, right, basically I want to get the maximum element in the heap while also removing it, right? So then procedure is basically going to be, let's say this is a heap that we have. So then the idea is you will first set up whatever is the last present leaf, right? You will send that up into the location of the root, right? So we remove the root and put the value there, right? And now we then compare um, the elements present with whatever remains, we'll check with that, right? So basically in this case, what will end up happening is we'll say, okay, so 12 you have to compare with both children, left child and the right child. So hence we need the reverse mapping. That is, we want to go from parent to compare with children, both the children, right? So we compare 12 with 10 and 23, and we'll replace it with the maximum of the children. So in this case, it will be 10 and 23. 23 is the maximum one. So we need to exchange between the parent and the right child in this case, right? So once you exchange that, you will have 23, left tree remains unchanged, right? And 12 comes here, and then 11, and then again you check whether 12 and 11 are having the property of heap or not, and they satisfy this property, and therefore you stop here. Okay, so this is a delete max operation, and this is an insertion operation in a heap. Fine. How will we do the heap sorting, by the way? Given a max heap, how would you do the sorting? Okay. Heapify is converting a list to a heap. Let's say you're given a heap. How do you do heap sort? So this is a heap, right? In this case, so 23, 10, 12, 4, 6, 11, right? Now this is a list given to you as a heap, right? How would you do the heap sort? So what you will do is basically you will this is a heap that you have, right? So then what you will do is you will say, okay, remove the max element, right? So then what will happen is you will have you will get a valid heap up to this location, right? And you will put this 23 here in the last location. Fine. Whatever remains is again a valid heap. Again, remember, when you delete max, you will get a heap back. I mean, that's the whole idea of maintaining the heap structure. So once you do that, you will have a heap here again. Yes, you'll have a heap here with 23 in the last location, right? So now you will say you delete max from this new heap, from this reduced heap that you have. Okay, so then you'll have 23 here. The second maximum element, for example, in this case, it will be 12, for example, right? And then you'll have another heap in this, a smaller heap again, right? And keep on doing this over and over, right? So then what will happen is you will end up getting a sorted array, sorted list. Fine. This is the idea. Again, remember, this is, yeah, so we are looking for, I mean, it's like, in a way, it's like selection sort, because what you're doing is you're saying you select the maximum element and put it in its location. We know what the location is going to be, but the internal working of the heap makes sure that when you delete something, uh, your next element, whatever the max element is there, it's ready to be used, right? That is the main point between your selection sort and heap sort. In selection sort, you have to go through the whole remaining of the list all over again, like from the scratch, right? So because you have no idea where the second maximum element is present, or minimum element is present, right? Whereas in heap, you get that information, so hence it becomes faster. And this is why it makes it as a n log n operation. Fine, because your delete max operations are taking log n. So delete max, okay, takes log n number of steps to complete, a log n number of comparisons, right? And you will do this delete max n times. How many elements are there? Each time you will do a delete max, so you'll end up getting n log n. Fine. So this is about heap sort and heaps. Heapify, again, remember, it's the same sort of, it's very similar sort of an idea. What you will consider is, let's say you have a random collection of elements in as a list. Okay. You will say the leaf nodes are already a valid heap, correct? Because, see, again, remember, there is no need, the leaf nodes need not have any specific ordering among them, right? So hence, whatever you put the elements in heap, in the leaf nodes, they're a valid heap, right? What we just need to compare now is basically the internal nodes, basically these nodes, right? So whatever comes out of these levels nodes, you just compare them whether they are satisfying the heap property or not. If they are not, you just start doing the switching, right? Okay, so this is about heaps, heap sort, and all of that. um yeah, this is all the time we have today. Exception handling, remember, try except conditions and else condition, that will basically help capture any issues in your code. Fine. um I think the last sort of complex thing that remains is the tree implementation. Basically, that's your binary search tree, right? So which again, remember, so binary search tree is basically just a sorted way of representing values. Okay, BST or binary search tree. Let's say if I have 10, 20, 40 being inserted in a binary search tree, what you will do is whatever the first element is present, that becomes the node, root node, right? If a value is greater than the root node, it goes towards the left, so right, right? And if it is smaller, it'll go towards the right, left. That's it. Okay, this is the simplest rule that the binary search tree has. So in this case, what will happen is you'll have a binary search tree like this. Okay, so 10, 20, 40, and then 4. Fine. So so searching becomes very simple. Deletion has insertion becomes simple. Deletion is a bit complicated, so just be aware of that. Okay. To the right, that's correct. Already sorted. Okay, I think I covered everything. Yeah, so queues is again, so we haven't, I mean, the course doesn't go in that much detail about queue. So queue is basically just a FIFO sort of a thing where you append elements one after the other. But when you want to get elements from that particular structure, you take the one which is inserted first. That's the idea behind queues. Okay, it's not very cleanly explored in this course. So yeah, I don't think it's that complex yet here. Okay. Same thing with stack also, because stacks also it's just mentioned in passing. It's a LIFO sort of a queue, right? When you enter a lift, for example, a very small lift, right? So if you enter first, you will end up becoming. I mean, you will leave the last, right? That's the idea behind stacks. Queue is basically when you're going to the bank and you have, let's say, one line, one single file, then whoever enters first will be served first, and so on. Okay. Fine. So this is all the time we have today. All the best for your exams, and any last minute burning questions we can take. Lexicographic dictionary. Yeah, I had that in my. So we have discussed that in detail last. I mean, actually, yesterday itself. So and it's uploaded on YouTube. You can just check it out. The exact procedure is discussed. Okay, and I've also given the code for it. So in case you keep getting doubts, you can just check the code and see what the output is coming in. Okay. Anything else? Okay. So all the best for your exams, and yeah, thanks for joining today.